Plants are often seen as immobile and unresponsive, but Darwin sees them as active with interesting behaviour. The very summer he first studies insect-eating plants, he also explores the ability of plants to climb. Like most Victorian botanists, he knows that plants grow upwards because they need light to survive. But Darwin is the first scientist to ask how they climb. He suspects it's all to do with the behaviour of the plant's tendrils. Climbers grow too slowly to observe directly, so Darwin has to find an original way to record their movement. For this experiment, he uses the American wild cucumber, which moves a few millimetres per hour.
There we are. Now this is quite a simple way of measuring a plant's movement, and it's something that Darwin used. And the principle is that we've got a consistent marker at the back there, which is a tiny little dot just here, look. A little pin stuck on there, and that stays there permanently. And that gives me a little measurement that I can look with my eye. I look through this glass panel, and I line that yellow dot up with the tip of the plant, like that. And I've got to keep fairly consistent here. And then with that, I just put a little mark on the glass. I use these stickers, in fact, like that, there. And then if we leave it for a couple of hours and come back, that should have moved. I'll turn my back, it might suddenly move.
The great thing about this is I've been able to trace the movements of the plant on the glass. It's Darwin's version of time-lapse photography and allows him to follow incredibly slow plant movements over many hours, even days. He notices something really interesting. You might assume that the plant climbs vertically, like this. But in fact, Darwin discovers that the plant moves round and round, like this. Always curious, Darwin wants to know why the plant tendrils spiral upwards. He goes back to the greenhouse to try to find out. He watches the wild cucumber over several days and sees that as soon as a tendril touches anything, it grabs hold of it. The spiral upwards is a searching movement. Circling increases the chance of a tendril bumping into a nearby branch or support. Then the plant uses it to climb upwards. Darwin discovers that other climbers have evolved their own ingenious techniques. This hop plant hoists itself up at a rate of several feet a week by using its leaves to cling onto the wall. The bignonia sends out super-adhesive suckers into the dark crevices of other plants, or this rope in Darwin's greenhouse. Different plants evolve different ways to survive. It is this fascinating range of behaviour that so intrigues Darwin. And botanist Professor David Cohn.
Great number of plants in here.
See that?
Beautiful.
Beautiful picture, perhaps?
And then here we have the two climbing plants that we're interested in.
Yes. Think of plants growing in forests, and you're not a woody plant. How can you survive in a forest? You need light. So what climbers have done is evolved ways to use the forest as a kind of trellis to get to the light. I mean, obviously for plants, it's all about getting to the light so they can do photosynthesis, produce food, and live. And this is a special adaptation, a whole, sort of way of being a plant as a climber.
It's a cheeky way of getting to the light, isn't it? If you've got a big tree that's taken 200 years to grow, then one of these chaps scrambles up the side of it.
Right. This is the thing that attracted Darwin. It's plants having behavior. The big parallel is to the insectivorous plants. They eat, chomp on meat, Plants are not supposed to do that, but they do it because they live in this strange environment which is low in nitrogen. These guys live in a strange environment that's high in forests, high in trees, and they have to find their way.
So the problem solving.
Problem solving, yeah. And that's what Darwin thought evolution was all about, and that natural selection is the mechanism for doing that.
For Richard Owen, Darwin's concept of evolution makes a nonsense of the natural world.
In every single one of these cases here are lots and lots of trays, like these guys here, full of insects.
Owen is particularly opposed to the idea of natural selection, which is Darwin's explanation for all these types of beautiful insects. Animals produce many offspring, but only the strongest, healthiest, and those best fitted to the environment survive. Over millions of years, this process of natural selection has led to the evolution of all species.
Look, 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 they're like, like different emeralds and sapphires. Look at the colour. Greens, blues. Oh, there must be a creator, that's the answer. But to suddenly sit back and say, actually, no, these forms they've all evolved from one ancestor, is remarkable.
Richard Owen has his own very different theory. He believes that God created a series of archetypes. These ancient creatures then became the basis for the development of all future animals in that group. Unfortunately for Owen, no one has found one of the divine archetypes that would prove his version of creation. But all this is about to change with the discovery of one of the most famous fossils of that era.
In 1862, Owen bought this fossil for his museum. It's about the size of a pigeon and was dug up in Germany. It became known as Archaeopteryx, or ancient wing. Now Owen was beside himself with joy because this was the very first fossilised bird ever discovered, so he gave it pride of place in the museum.
For Owen, Archaeopteryx is the original bird created by God. Darwin and his supporters see the same fossil in a very different way. The bird with its splendid feathers also has the teeth of a reptile, and unlike any living bird, a long bony tail. For them, this is the link between birds and dinosaurs, and powerful evidence for the theory of evolution. But there is still much for Darwin to understand. On his travels around the world and on the Galapagos Islands, he had seen many things that intrigued him. Take the spectacular frigate bird. They seem well adapted to flying and fishing, but they also have huge red throat pouches. Decorative features like these red pouches that seem to offer no advantage to survival start to puzzle Darwin once he's back in England.
This is why I'm at a farm in Norfolk to visit a particular bird that Darwin loved, and it's a real dandy of the bird world, the peacock.
Peacocks are originally from India. The splendid tails of the males make it difficult for them to fly and to escape from predators in the wild. The fact that peacocks possess tails that seem to offer the bird no obvious advantage worries Darwin. If he cannot work out why these tails have evolved, then his whole theory of evolution would be flawed. He is so perplexed that he writes, "The sight of a feather in a peacock's tail, whenever I gaze at it, makes me sick." I've arranged to meet peacock expert Marion Petrie and peacock farmer Quentin Spratt to do an experiment that Darwin proposed.
Hi. Must be Marion.
Jimmy, pleased to meet you.
Hey, Quentin, how you doing? Amazing
Yeah.
place. I've never seen so many peacocks. So I've got about 8.
8.
Right. So how many have you got?
Probably about sort of 700.
Jeez.